Okay, today we're going to add to the power rule by learning the product and the quotient rule. Now, the first thing you need to remember is that the derivative of the product of two functions is not the product of their derivative. Not. Remember that. So say you have a function, f of x is equal to x squared plus 1 times x cubed plus 3. If you multiply that out, if you FOIL it, you'll get this. Now, using the power rule, let's take the derivative of each piece. We get f prime of x is equal to 5x to the fourth plus 3x squared plus 6x. Now, to show you that it's not the product of the derivatives, we'll multiply each piece, their derivative, such as x squared plus 1, the derivative is 2x, x cubed plus 3, the derivative is 3x squared, and you get 6x cubed, which is incorrect. Alright, the correct way to do it, if you have the product of two functions, is to rewrite the first, take the derivative of the second, rewrite the second, and take the derivative of the first. I like to think of it as d dx of u v is equal to u dv plus v du. You'll use u and v later on in calculus next semester, so it's kind of nice to get used to it. If you don't like that, a shortcut of writing this rule is just to leave the x's off, and you write f g prime plus g f prime. There it is. You have to remember that. Okay, so let's practice this. Here we have the function, the product of two binomials. If we write this as u and v, f prime of x is equal to the first, which is u, the derivative of the second, which is dv, plus the second, v, times the derivative of the first, du. There I took the derivative of the second in each piece and the derivative of the first. If I multiply it together, I get this and collect like terms. You get this. Now you might say, why didn't I just multiply them and then take the derivative of each piece? Well, that would be okay in this one, but if you had something raised to the 10th power, you probably wouldn't want to do that. Or if you had a trig function, you couldn't do that. So you need to know the rule. Alright, and here is a trig function. So if I call this u and this v, I'm going to have u dv, the derivative of sine is cosine of x, plus v, and I need du. Now remember, we can write this as x to the 1/2 sine of x, so that when I take the derivative of square root of x, I think of it as 1/2 x to the negative 1/2. Now we need to simplify that. So if we continue on, we've got root x cosine of x plus, and I can put the sine of x up top in the numerator and 2 and either x to the 1/2 or root x in the denominator. And there it is. Ooh, here we have the quotient rule. And again, it's not the quotient of their derivatives. It's a little harder to remember. So you have the product of f over g, and you're going to take the 1 in the denominator, g, times the derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. Well, that's a lot to remember, so I have a song to help you. If you call the numerator high and the denominator low, it goes like this. Low, D high, minus high, D low, all over low, low. Okay, you might be laughing, but it's going to help you remember the quotient rule. And I bet you'll be singing it before long. Let's look at a problem. Okay, here we have the function of 3x squared over x cubed minus 1. Now this is high and this is low. So the derivative is, now remember, you start low and you end low. So you go low, D high, minus high, D low, all over low, low. Now you do not FOIL out or multiply out the denominator, but we do have to clean up the numerator. And to do that, doesn't look too hard. If I distribute, I have 6x to the fourth minus 6x minus 9x to the fourth all over x cubed minus 1 squared. We have like terms, so that's negative 3x to the fourth minus 6x all over x cubed minus 1 squared. Now I don't think there's a common factor to numerator and denominator. In fact, now I see that there isn't. But if you wanted to check it, it would be okay. You could take out a negative 3x and you have x cubed plus 2 over x cubed minus 1 squared. If there were a common factor, you'd want to simplify it. So either one of these would be okay, but I want you to match the back of the book. Match Bob. That's because half the AP test is multiple choice, and if you can't match what answer you got with the answer down at the bottom on the A through probably E, then you're in trouble. So match Bob. B-O-B. You got it? Alright, here's another one. X squared minus 1 over x squared plus 1. This is high and this is low. So here we go. Low, D high, minus high, D low, all over low, low. Now, that was easy enough. The simplifying is sometimes the pain. But this one, I'll show you a little trick. Doesn't look too bad. Notice that there's a common 2x in both terms. So if I factor out a 2x, which means you just divide each term by 2x, write what's left. Don't forget to subtract the negative 1. And it looks like it's going to clean up nicely because you have x squared minus x squared, okay, and then there's a 2. So the final answer is 4x over x squared plus 1 squared. Alright, one more. Here's a trig function, the cosine of x over x cubed. High, low. Alright, low, D high, minus high, D low, all over low, low. Get it? Alright, let's simplify it. And this time I see an x squared. How about a negative x squared? And there's an x sine of x plus 3 cosine of x all over x to the 6th. Now x squared and the x to the 6 simplify, so you have negative x sine of x plus 3 cosine of x all over x to the 4th. And that's your f prime. Notice my notation. When you're done, make sure you write f prime of x. Now I'm just going to go ahead and distribute that negative back because I'm thinking the book will. If there were a coefficient in front, they probably wouldn't. But either one of those is fine. But remember, we're checking Bob. Good day.